We believe that the color of the gummy bear has no effect on the launching distance of the gummy bear. Furthermore, launching from the back of the ramp causes the gummy bear to land farther away than launching from the front of the ramp because the launching force is applied to the gummy bear for a longer distance at the back of the ramp than at the front of the ramp. Stacking more books under the ramp would increase the launching distance of the gummy bear, and we expect the gummy bear to gain more distance when the angle is flat because the structure acts like a spring. Therefore, the larger the displacement, the more force is required to push the structure down, and the gummy bear gains more potential energy, which results in launching a farther distance than a steep angle, which has a low potential energy.
The experimental units are 30 randomly selected gummy bears, which were either white, yellow, orange, green, or red, 6 of each color. The factor for each piece of the experiment is the height. The levels in the experiment are the different stairs, which increase in height by 15 centimeters. The first treatment is launching the gummy bear from ground level. The second treatment is launching the gummy bear from the first stair. The third treatment is launching the gummy bear from the second stair level. The response variable is the length, in centimeters. To randomize, we randomly selected a gummy bear from the bag until we had 6 of each color gummy bear. And if there was already 6 of a certain color gummy bear and another of the same color was picked, it was put back in the bag. We replicated the amount of trials per treatment. Each treatment group had 5 experimental units. We controlled the height and who was performing the launch.
The most effective experimental design method is simple random sampling. We use simple random sampling because each gummy bear is picked randomly and each gummy bear has an equal chance of being selected. We assigned each gummy bear a number from 0 to 8 and used the random number generator on the graphing calculator with seed number 1221 to choose which gummy bear to launch. We did not use repeats. Blocking proved to be ineffective because blocking is based on choosing a confounding variable, and we did not believe that any confounding variables of the gummy bears, such as color, size, or shape, would make a significant difference on the distance launched.
The experiment is first set by having 30 randomly selected gummy bears, which are divided by 3, the total number of groups. Therefore, 10 gummy bears will go to each group in level 1. The gummy bears are once again split. Therefore, 5 gummy bears will go to level 2. We first have to compare the sub-subgroups and then compare the subgroups, which are comparing the angles and then comparing the stairs. Our data, we created our contingency table. As per our experiment plan, we first analyzed the effect of the different angles. This parallel box plot is a comparison of the angles when the gummy bears were launched at ground level. The bottom box plot is the control angle and the top box plot is the changed angle. The minimum of the control angle was the same as the maximum of the changed angle. The same comparison is present in the first stair box plot and the second stair box plot. Therefore, clearly the trials in the control angle had much larger distances. We'll now compare the different heights that the gummy bears were launched, but keeping the angle constant. This parallel box plot is a comparison of the different heights when the gummy bears were launched, but at the control angle. The bottom box plot was when the gummy bear was launched at ground level. The middle box plot was when the gummy bears were launched from the first stair, and the top box plot was when it was launched from the second stair. Regardless of shape, center, or spread, the second staircase had the largest distance. The same is evident in the parallel box plot where the angle is changed.
Following our experiment, there are a few sources of errors that could be determined. One of them is the length from our launch point could be not so accurate, especially when we launch from the flat surface. The main source of error was the pressure applied by the person launching the gummy bear because the pressure can never be the same. Based off our experiment, we can conclude that at first it was hypothesized that the higher the gummy bear was launched, the further it would travel. Our hypothesis was proven true as the results and graphs showed that the length increased dramatically the higher the gummy bear was launched, in such a case with the second stair. In conclusion, the higher the vertical height, the farther the gummy bear traveled.